our experts in both of these are known as machine learning engineers because they can use the mathematical knowledge and statistical knowledge, combine it with their programming or software engineering knowledge, and develop very sophisticated algorithms. Then you have domains and business knowledge, which is what you have in the industry where these models will be applied. So if you look at the intersection between domain, business knowledge, and statistics, that is the domain of traditional research. So typically, if a business has some problem, they say, I want to increase my revenue or I want to reduce my costs. Tell me how I can do that using statistics or optimization. That would be the area of traditional research that typically happens in companies. Development. So if a business is operating, but they want to develop an app, they will um, sorry, yeah, they will develop softwares or they will develop applications, and that has been the traditional domain of IT departments in companies. They are there to develop apps, websites, algorithms, programs using traditional or classical programming techniques. So now you combine all of these three fields, then you get the domain of data science. So that, in a nutshell, in a nutshell, is what data science is about. Okay, so next question is it for everyone? So the short answer to that is yes. It is for pretty much everyone, as long as you have a passion for it and you have an interest for it. But if you look at it, things get a little bit more complicated. You have data science, as I said, people who are experts in data science, they're known as data scientists. And their main job is to optimize and enable the data for business use. Some of their core skills are like Python, R programming. They have to have some knowledge in distributed computing, cloud computing. They obviously need to have very good core knowledge, expert knowledge in statistics and math. And their main job is to take the data and to understand that data and to ascribe value to that data. Data engineer is more looking at the software side. So they are operationalizing the data. They are looking at how can the data be useful at scale? How can they provide it? How can they, first of all, how can they collect it from the customers or the business users? How can they transform it into something that is useful for a data scientist? So their main skills are data ingestion, extraction, transforming, loading data, database systems, distributed ecosystems like Hadoop, Hive, Spark, all those things, APIs, unstructured data, converting that into something that's usable by the data scientist. So that is their kind of domain of expertise. And then finally, you have these business stakeholders, or you can call them business analysts also. Their main area of expertise is to understand the business problem. So they need to know what is the actual business, how the customers or how the business is actually taking place. They need to have some intuition about the business. What are the problems? How can they solve them? So they need to have knowledge about critical thinking about the business. They need to have some intelligence about the business. They need to know some bits about statistics and maths, but not as strong as the data scientist. They need to manage the data. They need to communicate the findings. So the way this ecosystem works is that a data scientist will take the data which is provided by the data engineer. So the data engineer's job is to operationalize the data. Data engineer gives the data to the data scientist, who analyzes the data, extracts value from the data, applies complex or sophisticated machine learning models, and then the data scientist sends it to the business stakeholder with the results that here are the output or the results of this model. And the business stakeholder decides, how can I use this to drive the revenue of the company or to increase profits or to reduce cost in the company? And that is known as data monetization. And then the cycle repeats. Then the business may go like, hey, I'm not collecting data about my customers' demographic information. So they may go to the data engineer and say, let's collect data about our customers. Let's collect more data about our customers. So then it moves to the data engineer again, who then looks at the data, cleans it, operationalizes it, and then the cycle starts again. So that's typically how this data science ecosystems works in the business. If you look at the different roles that data scientists have, you have data analyst, you have a machine learning engineer, you have data engineer, and a data scientist. You can see which skills are more critical for which jobs here. Obviously, programming is important for all the four roles, but certain roles they require more software engineering knowledge. Uh, Such as data engineers, they need to know the software because that is their main area of expertise. A machine learning engineers needs to be very strong in their calculus and linear algebra and statistics. Uh, Whereas data analysts, they're more concerned about visualizing the data, communicating the results. So the data analyst would be more in this sector, the business analyst sector. Machine learning engineer would sit somewhere between the data scientist and the data engineer. Data engineer would be over here, and the data scientist would be here. So you can see what are the skills or what are the main like areas of expertise that are expected from these different job titles. When you go on LinkedIn or you search for jobs, you'll see these different job titles, but often it is not clear what exactly do they mean when they say we are looking for a data scientist or we are looking for a data engineer. So now hopefully, inshallah, you know what are these skills that are typically in demand for these different positions.
Now, quick question, Hassan Bhai, just a quick question for better clarification.
Yes.
So, which one will be applicable for freshers and which one will be applicable for experienced IT professional?
All roles are applicable for freshers and all roles are applicable for IT professionals. This is not you start from this sector section and then you develop your skills and go to the other section. It's just what is your interest, what is your ability, what you want to learn. It's completely on your aptitude and what is your interest, basically. Any other question at this point, Junaid bhai?
No, Tawab bhai, we are fine.
Okay, all right. Let's continue. So then the third part of this section, which is why is it so popular or attractive? We've seen that huge explosion in number of data science jobs. The demand is increasing. Businesses are starting data science teams. If you look at some blogs or some news articles, you think that there's a very rosy picture of what can happen. There's a huge amount. Obviously, they're also generally well-paid jobs. They reduce costs for businesses. They help drive revenue growth. They help improve the customer service. They help detect fraud. A lot of insurance and banking companies, they have sophisticated data science models for fraud detection. They have self-driving cars and smart pots and those. So there's so many applications of this that there is a huge kind of potential in this field, as I'm sure many of you already know. But later on in the presentation, I will also try to paint a little less rosy picture or try to show you some of the downsides or some of the risks with this career or with this field, which you should be mindful of when you start a career in this. But to summarize, we have the reason why it's become so popular, especially in the last 5-10 years, is the availability of data, which is sometimes too much. Right now, there's so much data that is created every day that we are suffering from a data flood or a data deluge. There is data recorded in social media. There's data because all the communication has moved electronically. We have records of chat messages, of social media posts, of telephone conversations, of everything is being recorded. Even your Google Maps history in your phone is being recorded and tracked by Google. There's so much data, and people are always generating new data, not just from businesses who are generating data about transactions and sales and quotes and things like that, but also people are recording their thoughts and feelings on blogs. They're blogging more. They're tweeting. They're putting posts on Facebook. So there's been a huge increase in number in amount and also quality of data that is available. Then this has coincided with the increase in relatively cheap computing power and storage. One thing with all these models is you always have to have the computing power to process huge amounts of data and to create insights or intelligence out of it. Then the systems are also getting, they found that once data science models are implemented, the systems tend to become more efficient. So this drives more growth in this field. There's also been a cultural shift in business decision making. Earlier, businesses or management, they used to work more on their own experience or gut instinct or their own knowledge. They did not trust so much statistics or data science. But over the last like 10 years or 15 years, there's been a cultural shift in management, senior management, who've begun to realize the value of tapping into data and using that to drive their business growth or to reduce costs. Because of this, also it results in a virtuous cycle of hype and investment. So because there's a lot of hype around data science, there's a lot of angel investors, there's a lot of funding from investors into data science startups. That further creates more hype because more more new interesting products are developed, and that cycle continues. Uh, and then further also making it more popular is that there is a very low entry barrier. Like it's not very difficult to start learning data science. Like it can be very complicated. Like the amount of knowledge and topics are so vast and there's a lot of complexity in it, but it's very easy to get started. And the other advantage is that it's mostly on open source frameworks. Most of the data science community, they work on open source platforms or open source programming languages like Python or so that kind of barrier which results, which if let's say one proprietary software was used like IBM SPSS or one of these proprietary tools which you have to pay to use, that would seriously limit innovation and people experimenting with that field. But because the culture around data science has been to stick to open source tools and open source methods, so that has stimulated interest and innovation in the field. And this is true even today. And as a result of that open source frameworks, there's a very active research community. And there's a collaborative mindset, I would say. Uh, until now it's changing, it's becoming more competitive, but still there is there, if you ask a fellow data scientist to help you solve a problem, they are very helpful. People share their ideas on various blog posts and forums online. So there's still this kind of like mindset where we we want to share the knowledge that we learn. There isn't this kind of mindset, at least not yet, where people are not willing to share their insights or new knowledge that they create from the science. So because of these reasons, it's become like very big, and a lot of jobs have opened up and a lot of research has come out. So the next part in the agenda is to give you an overview of basic concepts. So I'll start with what kind of problems we can solve using data science, what are the main disciplines or research areas, and what are the day-to-day tasks that a data scientist would typically do, just to give you an idea of what the job is actually like. So some of the applications of data science, you can look at different industry verticals, like in banking or insurance. They want data science models are used to predict whether a policyholder will make a claim on a policy or not. Like they can do that very accurately. Typically or traditionally used to have insurance underwriters who would take, they would look at the data of the applicant or the person who holds the policy. They would maybe spend 5 minutes, half an hour, 1 hour, maybe even a day to assess all the risks of that policyholder. And then they would say, okay, this is the premium we should charge this policyholder. But these days, data science models can do that very fast in a matter of microseconds because of the data that they have on past policies and past claims. So that is just one example, but you have all different types of examples where data science has completely transformed the business. So you have digital marketing, you have sentiment analysis. Sentiment analysis is basically where you're looking at product reviews or customer reviews, either what they submit directly to you or what they post online, for example, on Google reviews or something like that. A machine can read that, automatically read those comments and figure out whether the customer had a positive opinion or a negative opinion or neutral opinion. And that's because of the volume of all the people who consume different products, go to restaurants or visit places or stay at hotels. For a person to do this, it takes a long time, but a machine learning can scrape the web and get all the reviews for your product in a matter of seconds and analyze the sentiment. So you get a very quick idea of whether your product is succeeding in the market or not. I mean, I can speak, like we can have one presentation on each of these one topics. So I don't want to spend too much time on it, but like you can see that these are industries with different use cases which are already in very wide use today. So let's go into what are the data types that when a data scientist uses, what are the different formats of the data. Most of the data, or what is common today, is tabular data. So that is tables in rows and columns, basically. And the reason for that is traditionally that is how data has been stored. Uh, like if you have a transaction, you create one row and you put the customer details, and then you put the, whatever they paid for the product and so on. So that's just one example, but or you have a list of events, you can collect those events in particular rows and store them. So here the idea is the tabular data format. You can have records which represent data points. Data points can be anything, customers, events, transactions, um, you know, policies, products, reviews. Whereas the columns represent the features or the attributes of that data point. And typically this is in CSV format, XML format, or JSON format. Um, in text, we have it's starting to get very widely used because as I said, there's a lot of blogs, there's a lot of websites with a lot of text. People are posting online on social media and everything. Um, and there's a lot of documents also that are available. So text can be both structured or unstructured. So structured would be things like forms or reports or documents that are available, whether within your organization or outside your organization. Is basically a block of text that the algorithm then has to make sense of it. And these are typically stored in text format, JSON, or as tabular objects themselves. Then you have audio. This is also growing in popularity. These can be conversations, speeches, music, ambient noise. Uh, the main purposes right now is like to transcript the audio. So if someone is giving a speech, you may want to like look at the speech, like transcript it to text automatically. Traditionally, there were people who would do that manually. Like when let's say a politician gives a speech, then some reporter or someone will transcribe that speech and write an article and say, okay, this is the speech content. But these days you have algorithms that automatically do speech to text or text to speech, which is the reverse. Then you have images. This is also another very fast growing area. So the images can be stored as hierarchical formats. So if you are looking at things like recognizing handwriting of people, you may have a set of examples where they have letters A, B, C, D, how that person writes it. That is part of your training data set. Or it can also be nominal. So they can be examples of an object. Let's say you have an algorithm that is used to identify one breed of dog from another. So you take a picture, and the machine learning algorithm will tell you whether this is a Rottweiler, or whether this is a Chihuahua or some other breed of dog, whatever breed of dog is you're interested in, or you're just curious, what is that breed of dog? You can take the photo. The algorithm has a training set where it has a vast repository of all the images of dogs that you can think of, and then it matches it automatically to the closest resemblance and gives you the output. So that is actually a class of problems which we call object detection, or more generally machine vision, because it requires a machine to act like an eye, like it's recognizing objects as humans do. So that is again a very separate topic. We can go into that in a separate session, inshallah. Then you have video data. This can be an unedited footage like CCTV feeds or live streams, or it can also be edited video like you have TV shows or talk shows. And you can do all sorts of things in there. I really don't have time to go into all of these things in this presentation, but as you can see, the scope is very vast. You can do lots of things with data science, depending on what data you have and the quality of the data that you have. So let's just do a quick overview of the machine learning algorithms. So you have,
Tawab bhai, just quick interruption before we take on this slide. People have asked actually a few questions. So if we can address just one question, maybe from freshers' perspective.
yeah,
So and then move on to next slide. That would be helpful. Say one question is, I'm a fresher, just completed my B-Tech in mechanical engineering. How can I build my career in data science? So this is very generic question, but there are plenty of freshers in this session. This would be appropriate, I think, to
yeah.
address.
Yeah, I actually have slides on that. So if you want, I can go to that slide first, or if you just wait a few minutes, I will get to
Okay,
that slide.
fine. So you complete it first then.
Yeah, yeah. Okay, but it's good. People are asking questions. This is good. This is good. I will cover this very quickly because I realize most of you are new to this field, so you don't have much knowledge about this. But we have machine learning behind behind the software. There is some algorithm that is working in the background, and there are three main classes of these algorithms. They are known as supervised learning, unsupervised learning, and deep learning. Now, I don't have time to go into all of these in detail, but inshallah, if there's interest, I will have separate sessions to go into each of these different algorithms and what business use cases can they be applied for, and how you can solve problems, along with maybe a hands-on session if there is interest. So, data science project lifecycle, I will not spend much time on this, but basically, this is to show you that what is the process, like how do we solve an actual problem using data science. So, we start with understanding the problem. Uh, Getting the data sources, building the pipeline of the data so you have a reliable source of data. We wrangle the data, which just means clean the data, explore the data, understand the data, clean the data for building our models. Then we do something called feature engineering, where we transform, we create features, or we encode the data into something that can be consumed by the machine learning algorithm. Then there's a phase, this is like a very iterative phase called modeling, where we train the model, where we evaluate the models, we see what is the best model, we tune the hyperparameters, a lot of technical stuff that goes on in here. Um, and here this is like the main job of a data scientist here is to feature engineer and model based on the problems. And then once the model is successful, let's say we have a model and then we have some results, we can then deploy the model either as an application or some kind of just an output that, one, get some input from the business and you run some model on it and you send the output back to the business saying this is the results of the data science model. And once they accept it, that is typically the life cycle of a data science project end to end. When we talk about day-to-day tasks of a data scientist, again, I will not spend too much time on this slide. It's just few steps that you need to know. Like you need to frame the problem, you need to translate something which is an ambiguous request into something that is a well-defined problem. You need to collect the raw data, you need to process the data, you need to explore the data, you need to perform in-depth analysis of the data, and then you need to communicate the results. What did you learn from the data and what are the results? So if there is more interest, if there are questions about this, I will explain this in more detail, but in the interest of time, I will move on. So let me just give you a quick example of what supervised learning is. Let's say you have a problem. You want to predict a rental amount for an apartment. Let's say I live in Dubai, so rents tend to fluctuate quite a lot in Dubai. So this is a real problem. Let's say I have a house, or let's say I own property. I want to know what is the existing status quo model. Let's say right now I just use my intuition, or let's say right now I use some historical average. I say in the past 5 years, the average rent from this properties of this type was, 5,000 dirhams per month. So based on that, this is what I expect to earn this year. It's not very sophisticated, but it's something, because the reason you do this is because you need to have something to compare your model with. Because the danger is that you can apply data science to pretty much anything if you don't do this, right? But there's a cost involved. There's an investment in time and resources and expertise that is involved in solving business problems using data science. And not all business problems really need to be solved using data science. You only do it for where you really have something to gain from it. So it's very important that you baseline your model so you know what is the existing status quo, or the best case, or the, let's say, the current state of the art, and then you start by modeling it. So let's say here in this supervised learning, you have something called a output or a response. This is what you're trying to predict. So here we are trying to predict the rental amount and in like per year. So AED is dirhams. How much money am I going to earn as rent from a given apartment? So this is the output. And then the features for this would be things like, where is the apartment located? What is the size of the apartment? What is the number of bedrooms and bathrooms in the apartment? What are the amenities in the buildings? And so on. You can have like hundreds, thousands, millions of features even. In some problems, you have millions of features. So what you do is you first collect the data. You have the data, historical data set of all the apartments, or as many apartments as you can find. with all these features, and then you split that data into a training set, a test set, and sometimes a validation set. The training set is to train the model using an appropriate algorithm. That's where your machine learning expertise comes in. You understand the business problem, and you realize this problem can be solved using is best suited to this algorithm. Then once you feed in the data, you use the test data to see how well it performs on data that the model has not seen before. So the training data is used to train the model, and then the test data is something you use to test the model on to see, does this model work well for data that it hasn't seen before. And using that, you try to optimize the parameters of the model. Once you do that, you can do an additional validation step where you validate to make sure my trained model, my optimized model, works on a fresh data set that the model has not trained or tested on before. So those are the main steps in supervised learning. And once you have a good model that works, you basically deploy the trained and optimized model. So to give you an idea of what the data might look like, just an example, I have these features as columns, as I said before. You have the neighborhood, you have the size of the apartment, you have bedrooms, bathrooms, what does it have parking, does it have gym, what data. And as I said, you can have more and more features. And then you have the target, or what is the actual output, which is what you're trying to predict, which is the rent per year. And that basically, when the model consumes this data, and this is not just like tens or hundreds of data points, you're talking about like at least tens of thousands, if not millions of data points. That's big data basically. So then when the model sees enough of these examples, then when you send it one apartment and you say, okay, I have this apartment I live in JLT. So I have this apartment in JLT, 700 square feet, one bedroom, one bathroom. It has parking. It has a common gym. What is the expected rent for that? The model will automatically tell you that. So that is the kind of the output of the model. So a typical successful result of this model might be something like the data science model that we generated predicted rent 23.7% more accurately compared to the historical average, this baseline model that I was talking about, and 3.9 more accurately than human real estate agents. So real estate agents, they are experts, they are brokers, they know the market very well. So if your model outperforms the experts in the field, the human experts, that is a very good result, because experts are expensive, and they take time. Whereas a model can make a prediction instantly or very close to instantly. So that is a very quick example of what a supervised learning algorithm might look like. What about unsupervised learning? So in unsupervised learning, we have a problem. Let's say we want to segment customer behavior at some electronics shop. Here in Dubai, we have something called Emax Electronics. So once again, I want to baseline my segments. Now, if I'm running any business or if I have some electronic shop, I have some segments, market segments that I understand to understand my customers. Because the thing is, unless I understand my customers, I won't know which products to put on the shelves, what offers to give them, what promotions to give them. So already I have some idea in my mind what my market segments are. But can a machine do this? Can a data science model do this much better or much more efficiently? So the output here is the clusters of shoppers. A cluster is basically a group of customers who are similar in behavior to each other, but different from customers in another cluster. So let's say you have 100 customers and you have three clusters, cluster A, cluster B, and cluster C. You want to create cluster A with shoppers who have very similar behavior to each other in that one cluster. Then you have cluster B who have shoppers with similar behavior in cluster B, but different from those in cluster A. So there's some difference, there's some separation in behavior between cluster A and cluster B. So some of the features that we use in this is things like demographics, what is their age, gender, where are they from, how much time do they spend at the store per visit. If you collect that data, that's very useful data to have. How many transactions have they done in the past? How much amount have they spent per visit? Sometimes you have customers who just go in, check the items, and they go out. Like they don't buy anything. You have lots of customers in electronic stores like that. So, and this can go on. Really, that's where your domain knowledge or your business knowledge comes in, to know which features to look for or which data to collect in your model. Now, the main difference between supervised and unsupervised learning is you don't have an output. So if you remember in the previous slide, we had a target, or we had a Y variable, which is the rent, that the example that I showed you, which is the rent which you have the historical data for. That is what your model is trying to predict. Here, the model is not trying to predict anything. It is just trying to identify patterns in the data itself. So it is trying to see what are the behavioral clusters that you can get from the customers. So there is no target variable. There's no like thing to say that how accurate is your model, because your model is just looking at the data and clustering it based on what it sees in the data. But the reason a machine learning does this more efficiently is because it can look at millions of data points, and it can cluster on multiple dimensions. Like here it's 4 dimensions. Maybe a human can do this, can look at these 4 dimensions and come up with some cluster boundaries and say, okay, customers who are between age 25 and 40, and whatever, they fall into this cluster. Customers who do blah blah blah, they fall into cluster B, and so on. But it's not very accurate, first of all, and it's also very difficult for them to do it, especially when the number of features increases, when you collect more and more data. So machine learning model does this very well. The only thing is, as a machine learning engineer, you have to encode the features properly. So inshallah, when we have some sessions on unsupervised learning or clustering algorithms, I will go into this in more detail. So the job of a machine learning engineer is to select a clustering algorithm and interpret the results. If the clusters make sense, these can be used for targeted campaigns, such as A and B testing, promotions. It can be used for marketing, customer retention, churn prediction. They can be used for upselling or cross-selling. So data for this might look like something like this. Each data point is one customer. So you have the customer ID here. You have some demographic information about them, like age, sex, etc. Then you have the number of visits that they made based on how many times they came into the store. You know how many purchases they made. And then based on their purchase history, you can calculate how much amount did they spend per visit. So all these things, and this can go on and on. Like this is not limited to, as I said, a few dozen features. It can go into hundreds or thousands of features. And based on this, the machine will look at all of this and identify patterns in the data, and it will automatically assign these labels. So this customer belongs to cluster A. This one belongs to cluster B, and so on. So a successful output for this will be that the targeted promotions based on the machine learning generated clusters, they increase conversion rate from 0.4% to 2.1%. So a typical use case might be before, whatever clusters they had or whatever email campaigns they were sending out or whatever promotions they were running, maybe only 0.4% of customers converted using that promotion. But once you have these clusters, you can say, okay, I know what the customer in cluster A wants. I'm going to target my promotion to cater to that customer in cluster A. So because of that targeted campaign, you know what the customers in cluster A are looking for versus what those in cluster B are looking for. And so you are able to drive a higher success rate or conversion rate of your product. So this is the end of this section. So now we will get to what everybody has been waiting for, which is what knowledge do I need to start? What are the minimum qualifications and skill sets? And then this is kind of just a quick introduction, and then we will go into like how you can actually start for fresh graduates or for early career professionals, how you can start working in this field. So the knowledge and skills, as I mentioned before, you have those 6 steps: framing the problem, processing the data, performing in-depth analysis, collecting the data, exploring the data. So you can see there's a lot of skills and knowledge that you need to have. In fact, it is not possible, realistically possible, for one data scientist to be expert in all of these different skills. So typically you have like areas of strength and like areas where you're not so strong in, but it's that doesn't matter. The main thing is that you understand all the different things that you need to know, and you constantly work on improving yourself. So training yourself, what I recommend is that you start with maths and statistics, because that is the foundation of data science. So without maths and statistics, it's like a data scientist who does not know math, statistics, or linear algebra is like a human body without a soul inside, if I can use that analogy. So to increase your knowledge in maths and statistics, I would suggest signing up for MOOCs, open courses. Basically, in my experience, I found that classroom training is the best suited for this. And there are many free courses as well. You don't have to pay for these courses. If you go on Udemy or Coursera or other many other places. I have a link at the end of the presentation, which will tell you about this in more detail. Because in a classroom environment, you actually have professors who understand, where you're coming from. So they will explain things from the very basic, from the very ground up. They will start and they will give you projects, problems, and assignments and homeworks that will help you practice and actually internalize that knowledge properly. Once you do that, then I would suggest moving on to understanding programming and database if you don't know that already. So programming, I would say you can do that using videos or app-based learning. There are many, these days, there are lots of apps on your phone where you can learn R or Python. They give you like typical problems. They give you small code snippets where you can code and you can learn on the go. Even if you're sitting somewhere, you can learn it. And I would also suggest to start doing some personal projects, based on your interest. Whatever interests you, you can start making programs or databases for those projects, just to get a hands-on idea of what programming and database really is. Once you do these two things, then you can move on to gaining your domain knowledge and soft skills. Now, for people who are already working in the industry, as a professional, they already have some domain knowledge because that is the business or industry sector that they're working in. But if you're a fresher, if you don't have the idea of what the business is actually about, apart from what you learned in textbooks in your college, then I would suggest the best way is to read blogs, articles, books in that field. Uh, Find what interests you and just like read up on that industry. So, for example, um, I started my career in an airline industry. So I used to read airline news. I used to read interviews about like airline CEOs telling them how the industry was evolving. I used to uh, look at data about aircrafts, airplanes, and engineering, and all those things that are related to aviation in general. So for you, whatever interests you, you have to basically take it upon yourself to read and understand and gain knowledge in that business area. And this is a lot to do with your attitude and personality as well. If you have an open mindset, if you think, yeah, I can learn more, then this is very good, because then you will always be open to new ideas and new thoughts. And that will be very useful when you're learning. Because the problem right now is that college doesn't teach the knowledge that you learn in college or in graduate school even is irrelevant after like 2 3 years, because the industry is changing so fast that what you learn in college is useless, like more or less. So what colleges should be teaching is people how to think and how to learn. So the skill of learning is more important than what actual knowledge that you have. So I would suggest, once you have these two foundational skills, then you build your soft skills and your domain knowledge. And then finally, it's also important to communicate what you learn and your results. Because let's say a data scientist builds an amazing model, but they're not able to communicate to their managers or to the business or to the CEO. Why did I build this model? How can it actually benefit you? If they cannot do this properly, they're useless. They will not get hired in the first place. So, and the thing is, business users, you cannot expect them to be technical people. So once you've done all this learning, you expect, oh, everybody will understand when I show them, very complex graph networks and things like that. No, people in the industry, they want very simple charts. They want pie charts, they want bar graphs maximum, or they want tables of reports and things like that. So you have to take it upon yourself to uh, translate the complex algorithm to explain it simply. They say if you cannot explain a concept very simply, you don't really understand it, and that's true. So this is a skill that is also very useful to develop, and that's why I've kept it as last. The first thing is obviously you need to start with the foundations, then slowly build up your skill set. So within these topics, I've kind of listed some things that if you're going on Coursera or Udemy, you can do a search on these different topics and you can figure out which areas do you already know about, which areas do you need to increase your knowledge in, and move from there. For the communication and visualization, I would suggest, again, being more hands-on. So these days, Tableau, Google Charts, Power BI, Data Wrapper, they have free versions for trial, or where you can play with small data sets, build your own models, or visualize those models in different ways. So I would suggest experimenting with that on your own and studying real-world examples as well to see how people in the business actually communicate their results? What kind of charts do they generate for their results and output? So these are just some of my suggestions. So now the minimum qualifications. Now, if you look at a typical data scientist, they tend to be predominantly male. They are bilingual. Now, that's not related to the skills. It's just that these days the data science is everywhere. Like you have data scientists from India, China. So they know, you need to know English, of course, but they also know their native language. So that's the result. That's why they are bilingual also. And typically, if you look at it, the experience is not very high. Like it's 2.5 years at most. Even for myself, I started learning data science around 2016. So for me, it's been only 4 years since I've started learning this topic. 8 years in the workforce overall, so 8 years of experience. Not very old. They are. I mean, if you are a fresher, you should not be discouraged, basically, because most data scientists are in their early careers or mid careers at the most. Most of them have some programming skill, typically Python or R. And in terms of educational qualifications, most of them have a master or PhD or some graduate degree. So I would recommend if you are looking for jobs, they typically look for bachelor's degree in STEM field, science, technology, engineering, or math. And they require either a master's or a PhD in a quantitative subject. If you have a PhD, that is very useful because you can command much more salary. But that's a big investment. A lot of people, don't want to waste 5 years getting a PhD, and it's also very challenging to get that. But a master's is not that difficult to get these days, and I think in this job market, it's a minimum now. So next is the business or domain knowledge in some field. As I said, you can gain this if you are completely new to the industry. You can start reading articles and interviews and white papers and industry conference proceedings and things like that. You can learn programming in Python. And you should have some level of deep expertise in one of the following. Either you're strong in your statistics and linear algebra, or you're strong in databases and data structures, or algorithms, or cloud computing. So I think if you have these skills, you can apply for jobs and you have a very high chance of getting hired somewhere. So this is just for your information. Okay, so now what are the specific steps I would recommend for students, for professionals and managers? But before I do that, may I ask for the poll number 2 to start? So just so I have an idea how many people are there in each category and I can spend more or less time in those subjects.
Started the poll so people can fill in their answers.
We'll give it maybe 10-15 seconds and I will continue.
87% voted. Okay, so ending the poll now.
Okay, can I see the results? Okay, so according to the poll results, about 49% of you are freshers, about 40% of you are professionals or entrepreneurs, and about 14% are managers or executives. So okay, so I'll spend most of my time on the first bit, and I'll also spend some time explaining typical starting points for professionals, and I will quickly go over the managers and executives bit. Okay. So for students, what I recommend is kind of a 4-step process. Okay. And again, I don't go into this in a lot of detail, but if there is interest, we can do a separate session, inshallah, where I will give you step-by-step instructions on what sources you should look into. Because there's a lot of junk, if I'm being honest, there's a lot of junk online about, they'll tell you, oh, you should take this course, or you should read this, or you should sign up for this newsletter. and you need to like sift the kind of the good things from the gold stuff, from the basically the not so useful stuff. So when for a student, I would suggest the starting point is first you need to have some idea of what business or industry you are interested in. If you have graduated in some degree, that industry will be can be very likely to be the same thing. So, for example, I did my B-Tech in aerospace engineering. So, aviation industry was a natural fit for me. Um so if you work in some other field, whatever, as long as you have some STEM qualification, science, technology, engineering, math, you can select any business which is related to your field, and you can get started from there. And then I would say understand the challenges of that business. What are the constraints in that businesses? What are the opportunities? Talk to experts in the field if you can find them. They will tell you, because that knowledge is very, very useful to help you frame the problem or define what you can bring to the industry. Because as a data scientist, you're not kind of a part of a puzzle which just fits in and is replaceable. You're adding some real value to those businesses. So you need to understand the business well. Then you can move on to research, where you can start studying articles, books, case studies. There are papers, there are Kaggle winners. In that, if you go on a website called Kaggle, you will see competitions that different companies sponsor for their business problems. You can see what the winners of those competitions, what models they applied, what are their techniques and tools that they used. That is a very useful learning place. Then you should do some comparison. How have they traditionally solved the problem, or what are the new approaches they're using? Maybe in forecasting, they may be using ARIMA. ARIMA is a model basically which was used, is still very common in forecasting, like forecasting the price of stocks or prices of houses or something like that. But nowadays they may use something like XGBoost, which is a decision tree based model, or something else, or they may use deep learning. So you need to understand, for the type of business problem that you're trying to solve, what are the traditional approaches that are being used, as well as what are the new approaches that are being used. And this will also help you get an idea of what is the state of the art, what is the like the very cutting edge, what is the absolute best that science can give in solving that business problem, versus what is good enough. And the other reason for this is sometimes you don't need state of the art, because those models, they require a lot of investment. You spend too much time optimizing the model. You spend too much time training the data sets, cleaning the data sets and everything. So the return on investment is not there. So for a lot of businesses, you're balancing both the cost of investing in the data science model, and you're also seeing what benefit will I get once I apply that data science model. So for example, if you have a let's say 92% to 95%, most businesses will say no. Why will I spend $100 million on that? So it's also important to understand what is the state of the art and good enough, and what is likely to be used for that industry. Then, of course, you have to do some self-study and practice. So this, I would suggest you go in online courses, do your own pet projects. If you get stuck, because again, there's the knowledge is so vast, and there's so many topics, and it's very interdisciplinary, and there's a lot of overlaps between different topics, and the knowledge base is constantly changing. If you get stuck, or if you feel like this, I'm not going anywhere, don't get discouraged. You should just pick another topic in that same area and start with that, because you have to temper your expectations. You will not get everything in the first go. So you will understand a little bit the first time you see it. Once you study another topic, you will understand a little bit more. Once you study a third topic, you will understand how topic 1 and 2 are related. So it's a very nebulous kind of knowledge base that we have to acquire. So you need to keep at it. Just like study enough until you feel like you get some hang of it. If you get stuck, then just move on to another topic. But don't stop. Right? Don't get discouraged and say this is too complicated or this is too tough. And then apply yourself. So once you have the knowledge and you have the business idea and you have the research at your fingertips, then you should figure out more efficient ways of doing things. uh, as a fresher, when you're working in some company, any company, even if your job is not a data science, maybe it's just a simple, maybe you're a salesman, let's say. You're a salesman, you have no, there is no like data science, you don't even have a laptop. But once you understand these things, you know what are the actual business problems and how you can solve problems for the business more efficiently. And that is what makes you valuable to the business or the company and in the job market in general. So when you do that, you can then, let's say you're a salesman, but you figure out a new way of increasing customer conversions, right? Or you're a sales executive or something like that. Once you bring this to the business, they recognize you. Yes, this person has critical thinking skills. This person actually knows the business very well. This person has knowledge about data science and how to drive benefits from it. They will give you more responsibility. And that's how you start your career. Basically, you don't go like generally, you don't go to a company and say, hire me as a data scientist. Nobody will hire you because you have no proven expertise. Why will they hire you? You have not proven them anything. So to kind of jumpstart your career, you have to basically show them what you can do. And then once people see that you have actually done something, opportunities will come your way. You will see. So and at the same time, while you do that, you should document everything that you learn. So if you make some mistakes or if you thought something would work but it didn't work, you should always make notes of that. And again, as I said, if there's interest, I will go into all of these things in more detail. I'll give some what helped me personally. It may help you, it may not help you. It's really up to you. And always make sure to be connected with experts to talk to them. If you have questions, ask them, and so on. Okay, so that's for students. For professionals, I would say it's similar but a little bit different, because for professionals, you are already aware of the business that you're working in. And typically, if you want to pivot to data science, you want to use the knowledge that you have gained in your business and do some data science startup, or apply some data science concepts to the problem that you already experienced while working in your industry. So I would suggest select a problem in your current stream, brainstorm the approaches to solving it, and examine the overall feasibility. Like I said, if it seems that the amount of money or the investment that you will spend in trying to solve that problem using data science does not justify based on how much return on investment you will get, then probably it's not really a good idea to pursue that. Then you should research it. You should, because you already have that business knowledge, what you need to increase then is your knowledge of what is there in the academia. So if you've started working in one industry, let's say for 20 years, you may have lost touch with what is the current thinking, academic thinking on the subject. What is the latest research in that area? So you should read academic literature. If you are, for example, in electronics industry, you should subscribe to IEEE, which is a professional organization for electrical and electronic engineers. See their journals, see what is the latest research that is coming out. You should try to understand what is the data that is available now that was not available before. So maybe something has changed, some business process has changed, that now customers of your business are, or customers in your area of where the sector that you work in, there's more data available. So now how do you use that data? That is something you need to research. What are the applicable models that you can use to solve business problems using that data? And as I said before, the return on investments and the benefits, you should also try to understand. Then once you have the research down, you should try to prove your concept. So let's say you have a theory that, okay, we are collecting data on customers. How can I use this to improve my business? So you start with a sample data set, get a small data set, not a very big one, something that you can work with on your local machine, or even that you can open in Excel and start looking at it. Experiment with different algorithms, but watch for some pitfalls like overfitting and data leakage. This I will go into a bit more detail later because this is more technical. Um, but there are some pitfalls. When you're doing any data science exploration or analysis, there are risks such as overfitting or data leakage that you need to watch out for. And then once you have a model that works, you should communicate your results, you should document what you learned, and you should think about ways of productionizing your models. So once you have decided, okay, this model works, this model doesn't work, you should make note of that, what has worked and what doesn't work. And then you can go to your boss or you can go to your business and say, here is an idea that I have. We are collecting this data. By this model, we can drive revenue growth, or we can increase our efficiencies of our operations, or we can reduce the time that the customer service agent spends on the customer, whatever it is. For managers, as I said, I'll spend very quick time. Basically, as a manager, you're looking very high level again. You're looking at questioning the current assumptions and practices in your business. You're looking at where are the scope for innovation. You're looking at things like where is the market competitiveness? Are you less or more competitive in terms of innovation than the industry average? You also need to understand what data is available and what may be available in the future. And if it may be available, how can you collect that data within the legal frameworks? How mature is your industry in terms of data science? Is there some appetite for investment from the senior management to invest in data science teams? What are the growth prospects? So if data science models are implemented in your sector or industry, what kind of growth can you drive in your business? You should also network. You should attend talks and seminars by experts. You should connect with IT professionals, subject matter experts, industry leaders, experienced professionals, just to get an idea of what is the landscape, how they can help you. And they have a lot of knowledge. And as I said, because of this open source frameworks and collaborative mindset, people are always willing to share their ideas and knowledge. And then you can do some strategizing. You can conduct some POCs to demonstrate an idea, but you also have to keep your costs and return on investment in perspective, because you don't want, as I said, you don't want to implement a data science model for something that will get very tiny benefits from that. And the key is to start small with small projects using very small data sets, and then scale up if it works. That way you reduce your risk of failure. So if some model doesn't work out, it's okay because you didn't spend so much time and money on that. Okay, so now I want to go into a little bit about the growth and outlook of this field. What are the pros and cons of working in this field? Which jobs are likely to emerge or disappear within the field of data science? And is the current climate of growth and interest that we've seen over the last 5-10 years, is it sustainable? So as a data scientist, as I've been working for 3-4 years in this field, I can tell you some of the professional realities of this job. So there are lots of upsides. You have lots of opportunities. Um, Lots of jobs are being, even during this COVID lockdown period, jobs have been coming in. It's not like hiring has completely stopped. um, it is very intellectually stimulating. So because of all the different aspects that I described to you, you're trying to understand the business problem, you're trying to understand data, you're trying to understand algorithms. Uh, if you like challenging, intellectually stimulating work, this is the best for you. Generally, they're also well paid. There's also a lot of independence and flexibility that comes with the position. This is not a sort of job where you will be micromanaged by your manager, or at least not usually, because what typically will happen is your superior or your manager will give you some problem, some task. They say, okay, figure out this. Here's some data. Try to see what we can do, and then you'll have a few days to a week to examine that. And you, during that period, you're free to set your own priorities, your own tasks, your own kind of schedules and things. So it's very flexible. So if you don't like micromanagement, this is again very good for you. And because of all the different interdisciplinary and multidisciplinary knowledge areas that you have, it's very easy for you to specialize in a certain topic or to pivot to a certain careers. Let's say after 3-4 years you feel like, okay, data science, it's very interesting, but it's a lot of hard work. You can become an expert in that, and then you can go into some other related career. So it's very easy to do that. And of course you have the prestige, and people they respect data scientists. Data scientists are typically smart, so they respect them. But then let's look at the downsides also. One of the main downsides is that there's a very fuzzy scope of responsibilities. What I mean by that is that it's not always clear what is your exact job description. A lot of jobs, they'll tell you, okay, this is what you need to do. This is the list of things that you need to do. When a customer comes, you should do this. It's very clearly defined. And if you do those things well, you get your incentives, you get promoted, etc. But for a data scientist, the scope is not well defined. Nobody knows what you will be doing like 3 months from now. Forget, like, so it's not very easy for companies to define. You'll see like very long job descriptions on job postings in this field, but the truth is half of them or more than half of them have no clue what they're talking about. So because of this, you experience something called requirements creep, where The company says, yeah, we need to hire you to do this task, but then once you do that and you do it well, they'll say, oh, we need you to do this also, and can you do this also? Oh, we are not collecting the data properly, can you help us collect the data? Oh, the structure of the data is not correct, can you help us fix that? And it can quickly balloon to like very unmanageable proportions. So as a data scientist, you have to be consciously aware of making sure you limit your scope, like within your professional life, like how much amount of responsibility and task you're willing to take on. It can be tedious and mentally exhausting. It is intellectually stimulating, but because of the constant working on models and data, it can be sometimes difficult to switch off. If you working all day, you're thinking about a problem, thinking and thinking. Let's say it's 6 p.m., you're going home. It's not like you can just switch off. Yes, you went away from your work or you close your laptop, but the problem is still in your head. So sometimes it can be very difficult to kind of disengage or disconnect from or set boundaries between your professional life and your personal life. There's a lot of depth of knowledge and breadth of skills required, and it can be sometimes be difficult to get a hold of all this knowledge that is required. uh, as I said, related to the fuzzy scope of responsibilities, there are often not clear objectives, targets, or guidelines to work in this, and one is expected to immerse oneself completely in it. You'll see a lot of data scientists, especially those who blog online. They'll have their job, they'll have their 9 to 5 job, but then in the weekends they'll be blogging about, they'll have their pet projects, they'll be attending seminars, they'll be watching YouTube videos on emerging research areas. So it's kind of like people expect you to live, breathe, eat like data science all day every day. So if you have like your own personal hobbies, or if you have something that you say, okay, fine, I'm doing this job, but like after my job is over, I have my own interests or something not related to data science. It's it's kind of difficult to do that because people expect you to be always like on top of the latest research and on top of the latest algorithms. And this can also lead to unrealistic expectations. This is changing, slowly, but like in industries which are not that mature, where management has not implemented data science properly, or they're just starting out in the journey, they can have a lot of unrealistic expectations. So they can say, oh, data science, this is amazing. Artificial intelligence, yes, amazing. Let's give me a model in 2 weeks. That, like, there can be expectations like that, which is completely unrealistic. And until you explain to them all the steps that are involved in getting the data, cleaning it, so it's, like I said, it's changing as industries are maturing this field, but it's still, there are a lot of unrealistic expectations from the senior management on what a data scientist can actually do. So in terms of career specialization, some of the, as I said, as algorithms and systems, they become increasingly sophisticated and powerful. Certain specializations are witnessing growth while others are slowing. So within the field of data science, the data engineer, especially those who are in cloud and distributed computing, these jobs are increasing quickly. Deep learning experts, these are also in high demand. Natural language processing or natural language understanding experts, these are more to do with text processing or text mining, audio processing, audio mining, speech to text, all those kind of fields. That's what an NLP or NLU experts works in. So these are also starting to be in high demand. And then, of course, related to all of this, which I didn't really talk about much, is data governance, data security, and data privacy. This is over the last 2 years. This has also increased a lot. A lot of companies are now starting to be concerned about these issues. There are a lot of legal issues, a lot of governance issues that are related to data science. So if you feel like maybe you don't have the technical skills or you don't have the willingness to really study like linear algebra and statistics, this is a very good option because this can there's a lot of potential for jobs in this area as well, and it doesn't require that much technical knowledge. Some jobs which are more, I would say, like either stagnant or reducing slowly are some roles like business intelligence analyst, data analyst, or data warehouse engineer. Reason data warehouse engineers is because nowadays most companies are shifting from on-premise data warehouses to they're storing their data on the cloud increasingly. And sooner or later, you'll get to a place where all companies will have all their data in the cloud. So a data engineer specializes in on-premise data warehouses will basically become redundant. So that's something I would not suggest, especially if you're a fresher. Don't try to go into that data warehousing or something like that. Okay. In terms of verticals or industry maturity, certain things, as I mentioned, banking and financial services are very mature. They have a very well-established teams. They've been doing this for more than a decade. E-commerce, delivery, social media, web services, real estate also quite mature now. Retail and manufacturing as well. So if you look for jobs in these, typically these companies in these sectors, they are looking for PhDs or some people who can really add that extra state of the art to their models. So for person starting out, it can be difficult to break into these sectors. And then there are some sectors which are growing with significant potential, things like healthcare and pharmaceutical industries, transportation, travel, hospitality, telecom and media. So these companies are basically at the stage where they may have a data scientist team, but it may not be very big or very mature. They may be looking to hire new people, experts in machine learning or data engineers or machine learning engineers. So these fields have a lot of potential, and it's comparatively easier to sort of start out in these areas. And then you have these sectors which have like kind of just now starting on that journey. So they may have not even start they may not even have a data science team in these sectors. These includes things like logistics and shipping, education, although this is now changing because of all the COVID crisis, all the education and instructions moving online. So now schools and colleges are now starting to think about how we can leverage that data, that online data, to improve the quality of instruction. Government services, they're also starting to take an interest in how they can better provide services to their citizens using data science models, energy and utilities as well. So if you are starting out and you have some domain knowledge in this, or if you're, let's say, a professional and you're working in one of these sectors, then it's if you learn about these data science topics and maybe get a certification or something in that, then it becomes then you have like a lot of potential to like start data science practice within your company.
So one quick question, Hassan bhai.
Yeah.
What is the scope for B-Techs? Like you mentioned about PhDs and the scope for masters. So uh, in this field of data science, what is the scope for B-Techs in general?
if you
And
have
yeah,
if you have a bachelor's B-Tech in computer science, you can get started. Like you don't need additional masters or graduate degrees. But the thing is, with computer science, you don't have like domain knowledge or business knowledge. Uh, so you will typically start a career in, let's say, as a data engineer, or as a kind of a data analyst, or something that relies more on the software engineering side when we talked about the domain knowledge. So for a B-Tech person who is from, let's say, a non-computer science background, or from, let's say, some business, or let's say some engineering background, it's difficult, to be honest with you, because you need to show them that you have some advanced knowledge or some graduate knowledge in that field. And the main thing about graduate degrees or masters or PhDs is that it's not so much about the knowledge, but it shows that you're able to do research independently. In a bachelor's environment, what happens is the professors give you courses, you do the courses, you do the assignments, you pass the exams, and that's it. There is no situation. Usually, there's very little chance that you've experienced a situation where you're given an open-ended problem and you're asked to solve it. In graduate school, you have research projects, you have thesis that you have to write, which are open-ended problems, things that have not been solved by anyone else. So when you have a graduate degree, you're basically indicating to the market that I have experience in tackling open-ended problems. I know what it is like to do open-ended research, to be self-motivated and do that. I don't need some professor to come to me and tell me, oh, do this homework or do this assignment, or I'll fail you. Like, I'm self-motivated that way. I can do my literature review on my own. I can solve problems on my own. I can design experiments on my own. I can test my hypothesis on my own. I can, validate the results. I can present everything. I can do it independently. So that is the main reason for a non-computer science or IT graduate that typically industries look for masters or PhDs.
Okay, got your point. Now the relevant question would be, is there any certification exist in the market which any person can do the certification and they are valued maybe or they are they are valued similar to, let's say, master or capable of performing this job? Is there any certification that exists in the market? Uh, mm, Credible certification?
In the cloud. So this is a very easy pathway for people, let's say, who have a basic IT or software degree, and they don't really know which business to start in. But if you start by getting these certifications, it is very useful. And these are also very difficult exams to pass. In fact, AWS is a proper 3 hour exam. It's very difficult to pass those exams. So it's not like these are just certifications that are not valued. These certifications actually have value in the market. Hope that answers the question. Okay. So I wanted to go over some risks of over automation. So we are right now we've talked about data science as a very good thing. All the job prospects are increasing. There's good salaries in the field, and there's a lot of excitement and research in the field. But what are some of the risks that we face in the near to medium term if we automate too much? One of the things is that automation or data science will result in mass unemployment and worker displacement. Basically, the kind of problems that we are solving right now in the industry is such that maybe in 5 years, all customer service agents will become redundant because everything will be done by automated bots, chat bots, voice bots, call bots, and all those things. So that is a very real risk, and that can lead to a lot of like instability in the economic climate. Automation also has this problem where it accelerates economic inequality. Basically, the people who have wealth or who they have money, they can spend lots of money to get the best certifications, the best degrees, and things like that. They can get the best jobs, the most highest paying jobs. And then when they work in those high paying data science jobs, they can develop algorithms that will make all those low skill jobs like customer service, those kind of jobs which are at risk of automation disappearing due to automation. They can increase the process. So automation is unfortunately it accelerates that process of widening the economic gap. And it also results in concentration of political power because using data science techniques, political leaders are able to manipulate elections. They are able to influence opinions using targeted hate campaigns, using propaganda. It's kind of very lucrative for people in power to do these kind of things. Data can be used to exploit marginalized groups, minorities, and the poor. You can an algorithm can tell you how much money you should pay a laborer. Like you may have like traditionally governments have a fair minimum wage. They say this is the minimum wage that all workers should be paid. But if the data science can tell you, oh, maybe that worker, if you pay him even lower than that, he will still work because he has no other option or he's so desperate. So it can result in exploitation of people using data science algorithms. The poor can be manipulated, they can be exploited, minorities can be oppressed. The reason I'm telling you all of this is not to discourage you from this field. It's just to give you some perspective because typically, like I said, all the places you'll read, people are always optimistic. They're always trying to paint a very rosy picture. This is great. It's amazing. But as a human being, the job you're working for, it's not just a job. It should also align with your values that, the type of job you're doing does some benefit for humanity. Another concern is that privacy and civil liberties will be compromised. There is right now a huge debate about what sort of data companies can collect. Is Google Maps allowed to keep all of your location history? And if they keep it, how long can they keep it? What what granularity of data can they keep it at? So these are very like ongoing debates, and there's a lot of discussion upon this. Like what is the difference? Like what is the kind of right balance between the economic benefits of fully utilizing people's data and the risk of compromising privacy and civil liberties of individuals when you collect too much data from them? Uh, Another risk, and this is kind of well known, is people tend to become over reliant on automated systems. So when you have data that does everything automatically, you tend to like lose sense of what it is actually like in reality if you were to do things manually. This is not necessarily a bad thing, but in the short term, it can result in some issues. And then finally, algorithms or any data science model, they will have some parameters, they will have some design in the logic or in the implementation of that model. And the person who designs that model, he will have some inherent bias or sentiment, right? They will feel that when making some decisions or parameterizing some variables, they will have some idea of what is the correct way to define the constraint from to solving this problem. And the problem with that is because a human is doing that, they are kind of unconsciously or subconsciously, they are transferring their biases and sentiments into the algorithm. And that algorithm is then used on like the whole population. So these algorithms, they reflect the bias and sentiments of those basically in power, because those are the people who are designing these algorithms. So that is one of the risks. So at this point, I want to ask you the final or the third poll, which if you can start, we will just have a quick response to that. Yeah, by the way, there is no right answer to this. This is a debate. This is open topic. This is just for me to learn what you think. Uh, I this is like really your opinion. Um, and there's no right answer to this. So whatever you think is the most right answer, put that in. Okay. We'll give it maybe 10-15 seconds and we will close the poll. Okay, so the poll results show that most people think it is a very beneficial thing. Like I said, it is fair. That is also good assessments. 50%, sorry, so 15%, 1-5, think the technology can be misused. I was expecting a little higher proportion of those, but that's also fine. 1/3 of you suggest that it's too early to say things. People are not sure. And then 17% say that it doesn't matter one way or another. So there is no right answer. Really, it's an ongoing debate. If you are interested in this, you can read blogs and articles by industry leaders in this field, what they have to say. Okay, so we are nearly to the end of the presentation, and I apologize for running very long. But I wanted to close with some resources that I have for you. I will share this presentation with you, inshallah, and this will be forwarded to those who want it. You can click on these links, explore what courses are most relevant depending on your interests. There's some books that I have here that you can click on these links and start reading. And these don't require that much technical knowledge. Like for freshers also, this is very easy to start learning. Then I have, and obviously this, I will note that obviously when you're starting out your journey in data science, you need data, right? To practice different models or to start exploring data sets on your own. So you can look at these two links that I've shared here, where you can download sample data sets, which are publicly available from different government sources or companies which have made that data public. And you can start exploring them, try to think of ideas, how you can use that data in different business environments or business contexts. Then you have some news blogs and case studies, as I suggested. You should follow them to see what are the latest technologies, what are the latest trends, what is the opinion, or what are the models which are starting to trend, what are the models which are falling out of favor. Uh, you can click on this Jupyter notebooks. Jupyter is basically a kind of a coding, let's say, an environment for experimenting or exploring data. It's basically a type of a Python notebook. So if you learn Python, it's very easy to start using Jupyter notebooks. And a lot of data scientists use Jupyter to share their results and knowledge. Code Bullet, this is a fun channel on YouTube. If you're just very, like, let's say you're casual, you have a casual interest in data science, you don't really want to go seriously into all the details, but you just want to keep yourself aware. There's this one guy on YouTube who posts very cool videos about different problems that he solves himself using data science models. So that's this Code Bullet. You can check that out. So I think that is the end of the presentation.
Okay, Tawab, Hassan Bhai, Alhamdulillah, this was very nice presentation. Since we are also running out of time, but it would be appropriate if we can take maybe 2, 3 quick questions
Sure.
that can summarize the whole stuff. Maybe that basically that can guide people. So let's say you covered very well for freshers. How should they take next steps to move towards data science? Now, suppose somebody is 10 years experience or 15 years experience working in a particular domain, how should they go about it? Or would it be worth for them to embark into this journey?
Yes, I did cover that, although I may not have highlighted that part. That was the data science getting started for professionals. So if I go to that, uh, um, this is basically meant for people who are already experienced, 10, 15 years, 20 years. They are working in some business, but they have not started working in, or they have not started using data science, or they're not aware of data science models. So like I said, the advantage that these people have is that they already, what is your business, or what is the problems you have experience, what are the customers like, or what is the challenges, what are the constraints in that business. As long as there are business problems to solve, there will always be scope for data science. It is another matter whether data science is the best way to solve that problem, or is the most economic or cost efficient way to solve that problem. But as long as there are business problems that you're aware of in your industry, you can always apply data science to solve that problem, let's say more efficiently, or to reduce costs or things like that. So this slide basically, at a high level, it covers what steps you can do to start like transitioning to, let's say, a data science specialist role. If you want, I can cover this again, but I already covered this during the presentation. So
Okay. So it would be helpful if you could share the presentation so
I will
that we can pass it on to the participants. And the another question is there any institute in India, any institution which provides strong learning for this particular subject?
I'm not very aware of Indian institutions because I did not do my higher education in India. So
Hmm.
honestly, I cannot say one way or another. So uh, I don't know. Like this
Okay,
is a question
okay,
I don't
that,
have
that's
answer.
fine. We will find out, inshallah. Junaid bhai, any questions you noticed? Um,
Yeah, actually, most of them have already been covered in the previous slides, and some you have already asked them. But I think there is one more question which our participants haven't asked, but during the time of registration, many have asked me. Like they are mostly like confused as to basically people who are switching from professional to data science, from say other software background to data science. Their question is like, I'm a Java programmer or I'm a .NET programmer, and I want to move to data science. So I hear Python, I hear R. So what should I start with? So most of them are always confused about it.
Python. You should start with Python because R is used for mainly in academia. Both are equivalent. Actually, the both Python was started also by some guy in the 90s in his garage, and was started as a research project in some university. Over the decades, what has happened is R has become more widely used in academia. So if you're working as a graduate student, or you're doing a PhD in data science or something, the R programming language is more commonly used. and it has some very useful libraries. I would say in terms of like capabilities, they're both equivalent. But I would say R is a little bit more optimized for computational efficiencies. So depending on the data set, it can be faster to process something using R than compared to Python. But in the industry, Python is like the gold standard. Everybody knows, or most data scientists know Python who are working in the industry. There's a lot of literature on it. There's a lot of, if you go on Stack Overflow or something like that, there's any problem that you can think of, or any bug issue, or any idea you're not sure how to solve it, there are people who have already answered that question. So I would recommend Python.
Yeah. Thank you, Hassan bhai. Just one more question. Another question I see coming from people who are switching, mainly people who are switching or who have interest in data science, basically the professionals. Like some say that they have basic knowledge of maths. They have just math as one option in their degree course. So they wanted to know like how much maths is actually required. Like, I mean, there are some set of maths they only need to know, or they really need to be very much qualified in mathematics or statistics, or they can just pick some of the points, some of the topics in maths, which should be enough for data science?
Yeah, the answer is a mix, right? It's not really clear. It depends on the job also. Some jobs, especially at research labs, you need to know very deep knowledge about advanced linear algebra, multivariable calculus, and all those like maths topics to a high degree of detail. But in the industry, it's not like, the reason why I say like you need to have maths knowledge is that a data scientist cannot be a monkey. Because if you think that data science is just about like copying some lines of code, uh, putting some data into that code, letting the code do everything, a monkey can do that. Like anybody can do that. As a data scientist, you have to have some intelligence and understanding about how the algorithms are working. When you train a model, let's say you're using some generalized linear model, you need to understand, or you have to understand, what is that algorithm doing it in the background. It's doing it in a matter of seconds, but there is some process that is happening. It's doing something with your data that is making it, transforming it into a way that is useful. So to that point, you should know the math behind those algorithms. So if you want to like start from a minimum, I would say, if you know which models you're going to use, let's say you started a job or you started solving some problem, and you notice this algorithm works good. So I would say spend the time to try to understand what is the mathematics behind that algorithm. And I think that is a good place to start. Other things is optional for you. As you know, there's the knowledge base is limitless. You can keep going more and more deeper. Here you can see in this slide, I've pointed out scientific computing. Like, these are libraries basically of Python that you should know of. Statistics, you should know basics about things like means, medians, modes, averages, hypothesis testing, correlation versus causation, design of experiments, A and B testing, basic statistics, Bayesian statistics, probabilistic, those kind of like basic concepts you can start with. And then the others, it just depends on your use case.
Yeah, thank you. Jazakallah khair.
Okay. Jazakallah khair, Hassan bhai. So Alhamdulillah, we had a very engaging session and we got the idea, overview of data science, Alhamdulillah. So inshallah, we will conduct more such sessions, maybe go a little deeper into what you have shared today. And we will inform all our participants. Thanks for joining. Thanks everyone. سبحانك اللهم وبحمدك أشهد أن لا إله إلا أنت نستغفرك ونتوب إليك. Assalamu alaikum wa rahmatullahi wa barakatuh. For any remaining questions, you can put your questions at society.mp@gmail.com. Inshallah, we will try to get the answer. Jazakallah khair.
Jazakallah.
Assalamu alaikum wa rahmatullahi wa barakatuh.
Wa alaikum assalam wa rahmatullah.